This video is a series about basic Java programming for beginners, where I show some examples using Greenfoot, a gaming library. So this video is about loops and how loops work and how you can use them. In this case, I'm showing how to use them in games, but they're basis for everything in programming where we want to repeat something more than once or twice maybe. So I'll explain this. So a loop is basically in programming where we want to repeat some task. For example, here in this game that I made, I have this wizard here. It's not really a game. Again, this is a simulation. I'm not controlling anything. This wizard has these dragons. I know they look more like snakes, but this was what I had available. So this guy is a wizard and these are dragons and they want to kill him. They will move towards him, all of them at the same time. So in order to defend himself, he has this cool fireball thing that he can fire, and I put some auto fire on him and also aiming. So he will always just aim for the snake that's closest to him. And so let's try to run the simulation. So he shoots at the closest snake, and his fireballs are then killing them one by one. And I kind of timed it with some numbers so that he barely goes through with this. And to be honest, he cannot really die. I didn't implement that, but it's more to show. So you could imagine that you wanted to do a game like this. So when you create a new object in Java, you need the new keyword. So for example, if I want to create 5 dragons in here, now they are here because I put them in my world, but if I want to create 5 dragons, the way that I create a dragon, I can open up my code, just ignore the rest for now, but this is the code that actually puts in a dragon. So I say get a random number from 250 to 550. This is what this does, approximately. And the other one, 350 375 to from 25 to 375. So this one goes from 300 to 550. I don't know if that was what I said, but basically I'll get some random number which will place them somewhere like in this square over here. So this code actually, it only puts in one dragon. I can actually show you if I take the code here and put it out of this, which is actually a loop, then you'll see now I only have one of them. So the other thing that you can do in programming is copy paste code. So basically, if I wanted to create 5 snakes here or 5 dragons, I could just repeat this code 5 times and then I would have 5 dragons. 1, 2, 3, 4, 5. And that is pretty nice, right? So I don't need the loops. Why do you need loops? So the problem is, let's say I want and I would also need to change the variable names. This is why I have all of these errors. So I should go through with that if I wanted to do that. That would take a long time. But what if I want 500? Then I would need to put in 500 lines of code, and that would be horrible. So this is one reason why we need loops. We don't want to repeat our code over and over again. So if I put it into the loop, and as you figured out by now, this number is what actually states how many snakes I'm going to have. Before it was 5, now it's 500. It takes a while, and now I have 500 snakes, and he'll probably be a bit overwhelmed here. Yeah. Fortunately, his fireballs, they kill multiple snakes at once. I set it up like that. So if we want to have many snakes, we can do like this, and it's pretty cool. It's a for loop. But I'm going to start with a bit more basic loop than this for loop because it looks a bit scary if you're not used to loops because of all of this stuff, all of these weird things in here. So I'll try to go a bit to another kind of loop, the while loop, which is a bit more simple than this one. We don't need all of these things in a while loop. But it was just to show that, let's go back to 5 snakes so he can fight them off. It was just to show that this is how to create 5 snakes in a really easy way inside of my world. So loops are just a way of redoing code over and over. You can also imagine it's used, yeah, you cannot write a program without loops actually. Of course you can, but uh, if you have a programming language without loops, it's not able to do much really. So loops and if sentences and conditions, it's the very basis of every programming language in order to make it work. So let's try to look at the while loop. So inside of my, sorry, not the dragon, inside of my fireball then, yeah, sorry. Inside of my fireball, I actually implemented the fireball to use a while loop. I'm not sure while loop was the best one to use here, but it's just to show the idea of it, right? So let me explain. So I made the fireball so that the fireball is kind of intelligent, like a heat-seeking missile. So I made a constructor here on the fireball, which means that in order to create a fireball, I actually need a dragon, and then I set that dragon as the target dragon that I want the fireball to fly against. And when that target has been set, the fireball is going to turn towards the dragon no matter where it is. It's just going straight line for it, and then it moves 4 pixels each turn, and then it checks to see if it's touching any dragons, and if it is touching any dragons, they all die. But I can have a case with 2 dragons on top of each other, and I want both of them to die. The other thing I want is that after killing all dragons that the fireball touches, I want the fireball itself to also disappear from the game. So what I'm doing is I use this piece of, first I turn towards the target dragon. Maybe there's 2 dragons when I get there. I have no idea. I just know that I'm going towards one of them. And then I move 4, and then I check to see, am I intersecting any dragons? Do I touch any dragons? And I get a list of dragons that I'm touching. If I'm not touching anything, then I don't do anything. But if I'm touching the dragons, I'm going to remove them from the game. So the way that that works is that first I remember how many dragons do I actually have. So dragon size is the amount of dragons that I'm touching at one time. Normally it would be just one. Like I would touch one dragon, and then this would just be one. So what I'm doing is I want to be sure, because if I have 2 dragons, I want both of them to go away. So I go into this loop here. And this is the simplest loop. You already know about if conditions, like if and then some condition, true or false. And while is the same, with the difference that an if sentence does whatever is inside of it once, while keeps going as long as this evaluates the true. So if I put true here, this will run forever, and this is what you experience if you have a program that runs and runs and runs and doesn't go anywhere. Oftentimes this is because it's stuck in a loop, and the condition is holding it hostage in that loop. So in this case, you need to have a condition in this loop that will change over time so that it changes from being true or not true. The reason why nothing happens if there are no dragons is because I is going to be 0 if the size is 0. If I is 0, we can evaluate 0 larger than 0 will be false. So it will never go into the loop. It also checks here if the dragon size is larger than 0. This is the equivalent one for just for an if sentence. It will check once, and if the size of the list is 0, it won't do anything either. So these are both depending on if there are no dragons, then they won't do anything. It will just, and that means it will basically turn towards target, move, turn towards target, move, and keep doing that. So the interesting thing happens when it intersects at least one dragon. And it might be another dragon than the one it's actually trying to follow. That doesn't really matter. Any dragon, it will simply move, right? Any dragon, it will go in here. So let's say that we have one dragon. So in that case, the size would be 1. So what I do here is it's checking if 1 is larger than 0, which is obviously true. Then it counts down this variable here. So now I becomes 0. It doesn't change anything because it doesn't evaluate this expression until it has done the code in here. So although I becomes 0, it doesn't quit the loop or anything like that. I'll show how to do that at a later point. But for now, it just decreases the value by 1 by using minus minus here. So this decreases I by 1. Then we go into get world, remove object, dragons, I. So this one gets the element from a list of dragons. It takes the one I here. Now I is 0, and 0 is always the first element of a list, so I know this will get the first dragon of the list. I know that there is a dragon in the list because otherwise I would never go in here, so I don't get any problems that the list is empty or anything, or any crashes from that. And then I tell the world to remove the object, and in practice that means that the dragon disappears. And then later it's removed by Java garbage collection. So I don't need to worry about that anymore. So that is the case if I have 1. After that I go in here, the dragon size is, I didn't change the size of this list here. It's the same list. Because I remove it from the world doesn't mean that it's not here. So I then check to see if the size was larger than 0. And if it is larger than 0, then I simply remove itself from the world. So I say get world, remove object, and then I send this here. And this, in this case, is the fireball itself. So it kind of sends itself for destruction by the game engine, or the world in this case, and ultimately the game engine. So this is why both of them disappear. One of the questions you might ask yourself is, why don't I just copy this part into the while loop? So in this case where I have only one dragon, that would be fine because it only runs once. But I cannot remove the same object from the world twice. Then I get into some problems because if I already removed it, I cannot remove it again and the program would crash. So let's go for if I have more than one dragon. So let's say that I have 2 dragons. Then this number would be 2. And it would say, is 2 larger than 0? Yes. And it would count it down to 1. It would then get the element number 1 from the list, which is actually the second element in the list because the first one was called 0. So it would get element number 1 and remove that. And now it goes up here. And now, if you remember, I was 1. So now it says I is also bigger than 0. I count it down to 0. And now I get element number 0, which is the first element, and I remove that as well. So now I've removed both of the dragons. And this scales to any amount of dragons. 5,000 dragons, doesn't matter. Just keeps going and removing them. Then it checks the original size of the list. If it's larger than 0, I know I have removed some of them from here. And then I say, just remove yourself as well. So after killing all the dragons in the same place as itself, it removes itself. So it's a pretty complex setup, this thing here. Although it's very simple, the loop part is pretty simple. You have to think thoroughly to understand what's going on with I here. I'm counting it down and I'm actually changing the value right before I get it from the list because the list is 0 based, and yeah, so it can be quite hard to understand, but the most important thing for you to understand right now is just that you can put either true or you can put false into this list here. Right? These are the only options that you have. So I'm just using that information or that feature to go through the list like that. Normally, while loops are not intended to be used with an internal variable like this. Often they're used in other cases. I won't go through it here. I just I want to show you the loop that we often use for things where we have an internal counter like this, because you often need something like this. In all cases where you find yourself decrementing some counter and using that counter, what you really need is the next thing I want to go through, which is the for loop. And that's the one I said, it's a bit more intimidating, but let's go through it anyway. So I go back to the world. This is where I create the snakes when I start the game. And here you can see that there is no weird I minus minus here. I don't have any things here that I have to set up. I don't have anything in here I need to set up. It's pretty neat and nice. And if you've seen these lots of times, the only thing you need to know is this is the initial value and this is kind of the end value. And then it all looks the same. So for a for loop, you have to write for and then you put parentheses, and for then you kind of have three places, let's call them X, Y, and Z, where you have to put in some information. And in the first one here, you put the initial, let's call it the initializer. So first you put in the initialization, that you create a variable. It's just a normal variable. You set that to some value you want to start out with. In this case, I set it to 0. Then the next one is the condition. So that means that I set up the condition that this is going to run. So we can actually set up a for loop that's exactly like the while loop by typing something like this. So we could change the while loop that we had in the other piece of code with this code, and then it would work the same. So you could say a for loop is a while loop with extra steps, right? So while this while loop only takes this condition here, the for loop takes a bit more. And the last part of the for loop is called the increment. So this is where we change the value of our variable so that it kind of stops at some point. The big thing about for loops is it's easier not to get mixed up in within your code. So you're kind of setting the counting and everything in the top and not messing with anything inside of your code. So you know that everything that's inside of your code has nothing to do with the counting, and it makes it easier for you not to make mistakes, I would say. So in the case we should have actually used, in this case we should have definitely used the while loop for the code that we had inside of the other class. Let me show you. So here we should have used a for loop instead. Just like the one I used in here. Would have made more sense because we have the kind of counting built in. So whenever you see something where you need an initial value and you need to increment, decrement here, and then you have some condition here, you're kind of reinventing the for loop. So I would recommend a for loop in this case. So it's more to show you that the progression from this to this, that it's kind of the same thing, but with more steps. So this is the basic for loop: initialize a condition, increment. And normally we go from 0 to 5, but we can go the other way. We can put 5 here, change this to larger than, then it's going, and then count down. Then we can go backwards if we wanted something like the one in the fireball one. We could go the opposite way. So yeah, that's basically the difference between the two. Just to make sure that everything is clear, let me try to show you what it looks like, not this one, but the one in the fireball, what this would look like as a for loop instead. So if I want to change this piece of code into the for loop one, and I'm talking about this piece of code, namely, I could change it into a for loop by saying for, and I look at the initializer. This is the initialization part, so I can just copy that in there. And I use the semicolon for the next part of the for loop. If you remember from in here, the next part is the condition. So now I need to set when is it going to stop? And I know that for a while loop, the condition is here. So I can copy this part here. And then we need the increment. It's actually a decrement here. So I put that here. And now I have the same for loop as up here. Just in same loop implemented like this. I can see, yeah, that's because I already defined. So if I comment out this one, the program should work exactly as before because these two are interchangeably the same. So let's hope I'm right about this. Oh, something's going on here. Let's see, -1. Okay, so I made a mistake. Let's go find out. Yeah, so the problem here is that inside of this loop here, I'm decrementing the I after going into the loop, but here I'm kind of, or right before I take the element here, I'm decrementing. So I can actually move the should be able to just move the minus here. Let's try again. No, not enough. Let me think for a second. Yeah, problem is still the same because it's counting down after the loop. So I need to do something else. So let's go back to the same code. So the problem I have, it says in here that my index is out of bounds. So what it basically says is I cannot get element number 1 for 1. So I need to go from the size -1 here. So that is the proper way of fixing it then. And now they don't die. Let's go back. So let's see if I is equal to dragon sum minus 1. So again, now the next problem is I also need to change that, because if the size is 1, then I becomes 0, and 0 is not larger than 0, right? So I need to change that into equals. So not that easy. So now I can actually go back. So sorry about that small confusion. I hope it didn't confuse you too much. So, but this would be the equivalent. Let me just remove this so you can see how similar they are. So I need to change this a bit because I have to start with the first element 1 less than the size. So I do that artificially here by putting it here. But I can't do that here because I cannot put anything that touches I inside of the code. The idea is that we want it in this line. I can change the value of I in here, but then everything gets really confusing. So this would be the equivalent of this one. So I would recommend this code over this code because changing value here inside of it is often something that leads to mistakes. But let me outcomment this part again, and let's keep it as it was. So I just have the example here still. Yeah. So that's how while loops work, and this is also how the basic for loops, they work. Like this is a basic for loop going backwards, and this is a basic for loop going forwards. So we often need them when we have multiple objects, either in something that we call lists or arrays, something where we have more than one thing that we are saving in a list or an array, as I said, that we want to access one at a time. What we want to do sometimes, this is why I put break and continue here. We can also use break and continue, and I would discourage using this as much as possible, but sometimes It does work better with this. Especially I don't like continue, but I'll come back to that. So for example, if we're going through these dragons here, there could be a case where we would want to stop the loop for some reason. So let's say that this fireball could kill only up to 3 dragons at a time. So what I could do then, I could say I want to count how many I actually removed. So basically, I could say that if I is I could count. So let's do it in a bit of a weird way. I'll have something here called removed new variable, and then I count that up, removed plus plus. So now I'm counting how many I have removed. So it's a bit of a weird code here, but bear with me here. It's just to show the break. So let's say that we wanted at maximum to remove 3 of these dragons here. So what we could do then, that we can say that if removed is equal to 3, then we want to stop the execution. So then we just say break. So this piece of code, if we have 4 dragons, it would go in here with 4 as the size. It would count down to 3, and then it would take the 4th dragon, remove it, count that now it's removed 1, skip this one because it's only removed 1. For the second one, it would be 2. For the third one, it would be 3. And it would go in here and simply stop the loop. It would go from break, and then it would go back out here and continue the act method. So break, that one breaks the loop. Maybe we could say, instead of breaks the loop, we could say breaks out of the loop, because that's really what it does. So it kind of goes out of the scope of the loop, skips over anything else. Even if I had like a piece of code down here, it would just skip it and go directly out. So that's it for the break part, if we wanted to break at any point. Then the other one that we can use is continue. So what continue does is it skips over any other part that comes after this. So if I had any code here like do something, then it would simply skip doing this for that exact one. So that would be like, we could check if the dragon that we're looking at, if it's a red dragon, we might not want to remove it from the world or something like that, and then we can just continue. So what we would do, we would go in here, we would say something like if and then get the dragon, and then we might have something like a method called isRed that would return if the dragon is red. If I then just said here continue, then the code would go in here, and if the second dragon was red, then it would simply skip the rest of this code. This would have some really bad consequences though, because now it would skip over the decrementer here, and then it would just go into an endless loop. So the decrementer should be here instead. So of course there is no isRed method on dragon, so we cannot do this, but we could easily make something like this, check if it's red, make some of them red or something like that. Maybe the red ones were the friendly ones. So continue would then not remove them from the world. It would not count how many we'd removed, and so forth. But in general, I say if you can avoid using continue, it's a very good thing. The reason why I don't like continue and break is that from the old days, this was a lot how you were programming. We used something called goto commands, where you could jump in here and then jump into another line and back and forth, and it kind of created some weird spaghetti where you could go everywhere in the code and no one could find out what was going on. And continue and break kind of does the same thing. That being said, sometimes I find that you can do something a bit more elegant by using break. Not so often with continue, and I must be honest, I rarely see anyone using continue anymore, but break I see pretty often. But you can use break to your own advantage and also to get, and I think if you find the code is more readable when using the get method, definitely go for it. Readability is the most important thing, I think, in programming, because the computer doesn't really matter how we do it, if we use break or continue, and often also if we can optimize by using break or continue, it's often very little, something that the user won't get anyway. So it's more important that any colleagues or yourself coming back to this piece of code will actually be able to read it again. So that was it for like break and continue. The last thing I'm going to explain is the enhanced for loop. So the enhanced for loop is taking this a step further. So where the while loop kind of has it in an ugly way, the I here all over the place, the for loop had it like inline here with the for loop, but the enhanced for loop hides the counter altogether. You don't even need it. And how can that be? Let me explain. So if I go into the fireball, I think I used it in here. No, I can never remember. I used it here. Yeah. So one of the things I do is when I run this piece of code here, he needs to find the nearest snake or the nearest dragon. I look at it and think snake, and so the code for that, I put that inside of the wizard here. So I have a code called get the nearest dragon, and then I check if there is if there isn't any dragons, it won't do it. And I also have a cooldown, so he cannot just fire thousands of fireballs, or 25 per second, I think will be the maximum here. So yeah, so I have this piece of code here checking that, and then he creates a fireball that automatically goes towards it. We've already seen that. It adds the fireball in the world and sets back the cooldown, so it waits a bit longer before firing the next fireball. But the interesting part is the get nearest dragon. So I had like, I have like 5 dragons here. And which one of these dragons is the closest one? And this is pretty straightforward with some maths. We can calculate what is the distance in pixels to one of these. We use some simple math for that. I won't go into that, but I made a method here that calculates the distance to any actor in the game. So what I basically do is I get the nearest dragon by getting all the dragons first. So I ask the world to give me all dragons in the game. I get them into a list. And the reason why this can be done using an enhanced for loop is because the loop is kind of built into the list already. Sorry. So I first set up like a variable for what is the nearest dragon, and I set that to null because if I don't find any dragons, I just want to return null, meaning there was no dragon, and then you shouldn't do anything. And I put that code into the wizard here, like if it's not null, it will do this, otherwise it will skip it. So he won't do anything if there isn't any dragons left, which makes sense. So, and then I set another variable with the nearest distance, and I set that to the maximum value of an integer. I don't know why it's an integer, it should be double here. That was a mistake. So just simply setting it to the maximum value. So from the beginning, I just set the maximum value that can be. In this game, it will be nowhere near this high, but yeah. And then I go through, this is the enhanced for loop. So this is actually what it's all about here. So in the enhanced for loop, it's using the idea that the list already knows how long it is. It knows about all the elements in the list. So why not just ask for the elements one at a time from the list? And we can do that in Java just by writing for in the same way that we did the for loop here. But instead of putting all of the initializer, condition, and increment, that is hidden inside, that is hidden inside of the loop here. So it's using something behind the scenes called an iterator, and you won't see that. You'll learn about that probably later in programming, but that iterator is hidden inside of the list, so we don't see it here, or it's part of Java really. So we can simply just write for each dragon, and in other languages like C#, it's called for each. I really like that name. So you would write something like for each dragon in the list of dragons, I want to do this. So you can kind of think of this as in. So for each dragon, so this here I'm defining what do I want to call the dragons that I'm iterating through, the dragons that I'm trying to go through here, and which list am I going to get them from. And this one denotes in this list. So the next thing that I do is I calculate the distance to the dragon that I'm currently looking at. So what Java does is that in the list of all the dragons, it just takes the first dragon and gives me that. And I don't know which one it is. This is one of the drawbacks of this kind of implementation is that I will get, the only thing it promises is that it will go through all the dragons, but not really in any specific order or something. Normally it just comes out in the order they were put in. And I don't know the order because, that's something I did in the world class, so I don't know about that. So they simply just come out in a random order. But in this case it's fine because I only need the distance. I need to find which one of them has the shortest distance actually. So I calculate something, I call it the current distance by calculating the distance to that dragon. And I use my own little method here, so that's not important, it's just calculation. So this gives me the distance in pixels, and it's not an integer because when it's not like in a straight line, it can actually be like a floating point number, which double is, so that's just how it is. So don't worry too much about that. We could have made it an integer, it's just a bit more precision with the double. So for the next part here, then I check to see if the current distance to this dragon I'm looking at, is that less than the nearest distance? If this is the first dragon, it will be less because I set that to the maximum possible value that you can save into the memory. So it will be less. So I then say, okay, now the nearest distance is the current distance. So the distance to the dragon we're looking at right now is now the nearest one. And I set this variable that I call nearest, which is really the nearest dragon. I set that to the dragon I'm looking at. So basically, if we have multiple dragons, the first dragon that we encounter in the for loop will be set to the nearest one because no one can compete with the maximum value here. So then the next dragon goes in, and now the current distance is set again. And the current distance, now we check against nearest distance, which was the nearest distance from the last nearest dragon that we had. And if it's less than the one we already have, we set this to the nearest one, and then this dragon to the nearest one. And I just keep going like this, always remembering if what the nearest distance was. And then when I'm done, I know I have the nearest dragon in the list. And I simply just return it then to whoever is calling. So this is a good use for the enhanced for loop when you just need to go over, or iterate as we call it in programming, iterate over all the elements of a list. We might as well just use the for loop. So what would I recommend? So I would say in general, if you can use the enhanced for loop, I would definitely go for that. It's much less error prone and easier to read than any other thing. And sometimes you do need to know the index, or you do need to know the number or something that you're going through, or the structure you're going through doesn't have the ability to use the enhanced for loop, then you just should use the normal for loop. When should you use the while loop? I would say you use the while loop in very simple cases where you have only like one thing. One place where I often use the while loop is something like if you have input from a keyboard, you would just want to keep asking the same question until you get an answer that satisfies some criteria, which will be the condition. So you would put the condition here like is it a valid input, and then you would keep asking the user in here, please enter your PIN number or something, right? And then you check if it's the correct PIN number. If it's not, then please enter your PIN number. Please enter. Just keep going. Please enter. Please enter. Please enter your PIN number. So you could do something like that. There is one more thing. I'll leave it up to an exercise to you. I never use that. There is something called do while in Java as well. Another kind of while loop that you can use. It's very rarely used. And basically, it's the same, just instead of while, you just type do, and then you write what you want to do, and then you put the while condition here. So in the case like up here, you'd say I less than or bigger than 0. And the only difference between while and do while is that here it checks the condition before going into the while loop, and here it goes into the while loop and checks the condition afterwards. So I rarely see it used today, but there's no problem in using it. Sometimes it's nice to be able to do it like that. It's kind of up to you. I won't go into any details because it's not very much used, I think. But yeah, you can look that up yourself if interested in that. So I hope this gave you kind of an introduction to the basics of loops. I hope that you saw that you can actually use it for cool things, like if you want to spawn massive amounts of dragons, you can do that without having to use a lot of code, and maybe see things in a more visual way than usual. So that's it for me. So bye bye.